Hi, welcome to COMP501 Foundation of Programming. In this lecture, I will talk about Singly linked list. A Singly linked list is a data structure for implementing a list ADT, for which each node has data and a pointer to the next node. You can think about the linked list like a train, a cargo train, where each cargo are linked together to the next cargo. And the engine in the train is called head, and the last node is called the tail. A singly linked list is a type of positional list. That means um, the element contain pointer to the next or previous element in the list. There's a special value called null pointer, null null, which means it points to nothing. And this is very similar to or equivalent to none in Python. So here is a picture of what the node look like. Initially, the node has head and tail, where both head and tail are null. This is an empty list. And so this is what happened when I create a new list. I have an empty list with nothing. And then I want to append node 99, that means node with data 99 to the num list. And when I append the data, the head and tail, these are all pointer, now point to the data 99, and the data 99 node next point to null. This means no more data. This is the end of the train, no more data. And you can see that now if I want to add another node, and this is the power of a linked list. If I want to add another node, say node with the 44, earlier the node with 99, the next pointer will point into null. Now I can add the new data, the node with the 99 value, the next pointer, as you can see, now point to the data 44 node. And the data 44 node, the next pointer, now point to null to say this is the end of the train, no more data. The tail pointer was point to both head and tail will point to data 99 because there's only one data. Now with two data, the head it point to the first element, and the tail it point to the last element now. So these head and tail pointer keep track of where the head and tail of my data. Now if I want to add another node, 66, and this one I call it prepend. Prepend means I want to add in the beginning, not at the end. I want to add at the beginning. So to do this, I want to move, basically, I want to add 66 right here. Data was 66. So as you can see, I can move my head pointer to point to the data 66, and the data 66 next pointer now point to data 99. And maybe in a better analogy, maybe using like a semi truck, you want to move some semi truck in some position, and somebody can make room for the new truck in place. So the head of the line in the truck is now data 66, and behind data 66, like the next pointer, it points to data 99. And this is the idea behind linked list. A singly linked list only means there's only one next pointer that point to the next guy behind. So let's look at some operation here. The list append and the list prepend. Append meaning again append to the end. If we have a empty, so in this algorithm, treat this like a algorithm, like a pseudocode if you want, or like a real code. List this arrow meaning point 2, the list point to the head. Alright, so this is a head pointer, is if a null, which is in the beginning, yes, then the both head and tail is my new node, because this is when the list is empty, I add the first node. So this if statement add the first node, and this else statement would be adding if it's not the first node, like the second node, the tail that point to the next pointer, the tail that point to the next pointer now point to the new node. Now that means the next pointer is the new node right here, and then the list tail point to the new node. Whenever you add a new node, the next pointer you point to the null. Whenever you add a new node, the next pointer pointed to the null. And we are then adjusting the next pointer of the previous node and the tail or maybe the head, so that the data will be in order. For example, if you look at prepend, I want to add that in the beginning. Given this is my data, 23, I want to prepend a new node called 17 in front of 23. So between the head and data. So I want to change the head pointer point to the new node. So here again, if the list is empty, this is just add first node. Otherwise, I would the new node point to the next is what the head was pointing to the next previously. So head was pointing to data 23, so new node point to data 23, and then the head now point to the new node, and that's what it does here. The new node next point to what the list head was pointing to, and the list head now is the new node. The order of this statement make the difference, so do not change the order. You want to make sure you set the new data, the next pointer point to the correct next node, and then update the head pointer to point to the correct current node. What about insert? I can insert after. So I can insert after the head with a node 9. So if I have an empty list, an empty linked list, I insert, and again, this is checking whether the list is empty. If the list is empty, then the head and tail are the new node. Again, when you add a new node, the next pointer always point to null. Otherwise, if the current node is the tail, so insert after the tail, like the second case, then I want to insert after the tail, then the tail, as you can see, point to next. I want that to be the new node. So this is what this one does. The list point to the tail, point to the next is the new node, and now the tail is the new node. This gives you moving the data, so that gives you the next pointer, very important, point to the next correct new node, update the tail pointer to point to the last node. If you want to insert in the middle, like I want to insert node 9 in, I want to insert node 4 after node 9. Alright, I want to insert node 4, a data with node 4 after node 9. So I want to insert something right here. As you can see, with this point, the next pointer, all I need to do is change the next pointer, the new node next pointer, point to whatever the current node was pointing to, which is data 15. So I do the new node data 4, the next pointer point to data 15 first, and then the current node next point to the new node. So the current node was 9. Now the next node point to data 4, my new data. And this is again using the linked list, the pointer point to the next node. you can see how to shuffle or make room for the data so that the new node will be in the proper location, and the next pointer point to the correct node. What about removing a node? Removing a node is just basically you want to skip over. You want to skip over the data. You want to skip over. And in this case, remove after list null. And if I have a null, in this code, if current node is null and the list head is not null, that means this is my succeeding node. It's the head point to the next. I want to remove the first node. So this is my, in this case, succeeding node. No, this would be my succeeding node. If the head pointing to the next, if the succeeding node is null, no, and the head now point to succeeding node. So basically, this head now point to this node here. I just skip over. This guy is gone. I just skip over. If I want to remove the list after the node 4, so this is what it look like after I remove the first data. Now if I want to remove the list after node 4, which in other words, I want to remove this guy, I will check my succeeding node in my current node point to next. Kind of funny. You can do next. So current node is 4 point to next is data 5, and data 5 point to next is data 2. That means I want to move this guy over here. The succeeding, my current node is point to the succeeding node. This is my succeeding node. And my current node, data 4, point to my succeeding node. Skip over data 5. I broke the chain on data 5, and you might ask, hey, what happened to data 5 and data 9 previously that nobody point to it anymore? In a larger implementation, those will get garbage collection, meaning removed from the memory. And let's do another one. Remove after list node 4. So I want again remove after node data 4, which means I want to remove this guy. Well, if I want to remove this guy, so my succeeding node is now is a null. So all I need to do is I move my next pointer to null, and I also need to update my tail because my tail is this guy now. This is my last node. If my succeeding node is null, then I want to update my tail to my current node, which is in this case the data 4, but this is the last node. And to search, because if you think about this like a train or like a semi in a rest stop, that they have a long list of semi there or long list of cargo train. If you want to look for something, how do you search this? Well, this would be using linear search. As you can see, the data really not in order here. So this is basically is a linear search. What I'm doing here is I search the list with the key. So given the list, so I will start in my head, the beginning, the engine, the train engine, the beginning, while current node is not null. This means while the current node is not the end, it's not null, this guy here is not the end, current node point to the data. It says equal to key. If that's so, return the current node. If not, current node equal to current node point to next. So this would, I check my current node data is equal to this node, then my current node, alright, so this is my current node in the beginning. Current node equal to current node point to the next. Now my current node is the next current node, and then the next current node, and so forth. It will look for stuff until my current node is null. That means I did not find it. Return null. And in a singly linked list, the search is a linear search. And you can see this is one of the drawbacks here now, right? Because now you cannot have a binary search, which is not that efficient. Thank you.